Hi everyone, this is Dr. Andy Chen. I am from Datong Company and Datong University. In this session, let's talk about the introduction to the big data analysis. This is my profile for your reference. Well, we usually talk about the data. There are people taking care of the data. We have the data scientists and the data engineer. In this illustration, you can see the data engineer is at the left side, the data scientist at the right side. And they have different responsibilities, and they are taking care of different tasks. You can see that with the data engineers, they have to have the background from the computer science, engineering discipline, and the computer engineering. They are taking care of most of the software tool, the computer architecture or networking. Somehow at the data scientist parts, they mostly have the background about the computer science, the mathematics, operation research, and statistics. And you can see that they are taking care of most of the, what do we say, the business intelligence. Yeah. And they are working with a different platform. So you can see the illustrations here. There are the differences between data engineers and data scientists. And in this page, well, it's example. It says that the data scientists, salary is a little higher. Okay? And you can see they are hired by the Dropbox, the Microsoft, and the accounting company, the Walmart, or the engineers. Yeah, they're hired by the PlayStation, New York Times, Bloomberg, and Verizon. They are in different areas. Yeah, the hiring and the salaries are a little different. About the data scientists, we might think, they are the people taking care of most of the machine learning code. Yeah, they're taking care of all the AI stuff, and very, very complicated, very, very busy, full of mathematics. And of course, they have to take care of the data part, the collection, the configuration, extraction, the process management. Yeah, they have to verify the data and resources and infrastructures. Somehow in the real world, that's the data scientists really do in their daily life. The machine code is actually a minor part in their work. They're taking care almost all about the data pre-processing before they have to interpret the data analysis results. So we can see that the potential of the big data analytics. We say the big data analytics improves efficiency, productivity, and the results in higher, better returns. And it can create new products, new services, and new business models. And that brings the consumers closer to the businesses and become the repeat consumers. They come back again and again. Even the big data analytics help the managers make better decisions. Why today the big data is being taken seriously? You can see that every within 1 minute, 70 hours of videos are uploaded in the YouTube. Around 30,000 new posts are created in the Tumblr blog platform, and more than 100,000 tweets are shared in the Twitter, and more than 200,000 pictures are posted in the Facebook. They are all data. You can see that the data is blooming every minute, every day. The role of the data analytics in the organization. We can see the data in 4 layers. For the most bottom, the data we can say the raw data. It's not collected. It's just collected and not organized and processed yet. Like the signals, it's kind of know nothing about it. So when the data is given context, it becomes information. Yeah, the information is a little more useful. It's organized and structured. And somehow when the information be given meanings, it becomes knowledge. So knowledge is contextual, synthesized, and help learning. And the final stage, when the knowledge is given insights, it becomes the wisdom. So wisdom helping to understanding, integrated, and actionable wisdoms for the even better decision making and more. There are various types of data formats. We can say there are mostly structured data and unstructured data. Somehow they are a category of semi-structured data. We will see more about it later. Big data characteristics and the dimensions. Usually we will talk about the 5 V's of the big data. Say the very first one, the volume. That means a lot of information. Velocity, quickly determine which data needs to be stored and analyzed. And the value, data can provide value to the organization. And the veracity, the consistency and the reliability of the data. And the variety, different data sources and formats. You can see that the big data challenges the data volume, the ability to capture, store, and process a huge volume of the data in a timely manner. And the data integration, the ability to combine data quickly and at a reasonable cost. And the processing capabilities, the ability to process the data quickly as it is captured. Data governance, where we have to take care of the security, the privacy, and its access. And of course, the skill availability. Do we have sufficient data scientists around us? And the most important of all, the solution cost. We have to take care of the ROI. Now we can see the classification of the big data management. The goals of the big data management are about the 4 ones. Ensure the storage of the big data. Ensure the program to be processed continues to operate normally. And ensure the continuous operation of computing and application services. And of course, ensure the data security. You can see the illustration here. All the way up to the decision making. And the security is in every layer. The data storage. Relational, we have the relational database and the non-SQL database. Data table and the key values need to be defined in advance, and the changes are quite occupying, which is not suitable for the fast real-time requirements and the diverse structure of the big data. So the requirement for the amicity, consistency, isolation, and the durability are so strict. So in the non-SQL databases, there is no need to define the data structure in advance, and it can be simply expanded and changed to store various data, such as key value stores, column-oriented data, files, pictures, etc. This is the database history. You can see that ever since 1960s, the term database is coming up, and all the way till now, the non-relational databases. Yeah. CAP theorem. A distributed system cannot meet the 3 requirements of consistency, availability, and the partition tolerance at the same time, but at most 2 at the same time, please. Consistency. All nodes get the same data at the same time. Availability. Failure of one node will not prevent or affect the work of the running nodes. Partition tolerance. Even if the information is lost or the network or the node fails, the system can continue to run, and the errors can be handled through replication. CAP function distribution map corresponding to each database. Yeah, there's an illustration here. The consistency, availability, and the partition tolerance. And there are currently several different databases. They meet each of the qualities. Now we can see the 9 steps of the big data analytics. The very first one is the business case evaluation, then the data identification, data acquisition and filtering, data extraction, data validation and cleansing, and the data aggregation and the representation, data analysis, data visualization, and finally, the utilization of the analysis results. We can see the business model evaluation here. The data acquisition, data set confirmation, it is necessary to first find out which data sets are needed for this analysis purpose and their sources. Acquisition and filtering of the data, collecting this data and filtering those unwanted data. Then data extraction, we need to extract and convert data first, and then transform data format into the data format that we can analyze. About the data cleaning, data certification and the data cleaning. Establish the certification specifications and remove the unqualified data to increase the data quality. And the data aggregation and the reorganization, it means to combine the different data sets. Anyway, we have to analyze the information. So there comes the data analysis. The actual data analysis task is carried out at this stage. Combine the data mining and the complex data analysis techniques to discover the meaning of the different patterns and the relationship between these variables. And the use of data visualization. Use data visualization technology and the tools to graphically display data analysis results to the users. And finally, the utilization of analysis results. It focuses on the deciding how and where to use the analysis results, which would have a greater influence. So you can see the illustration on the right side. They are most of the very general example of the data visualization. The pie charts, the bar charts, and everything. The big data in the education industry, we can see that the personalized learning courses, redesign of the curriculum, design and objective scoring system. Teachers need to understand the strength and the weakness, interests, and the progress of the students, and predict the suitable careers for them. Like example, the University of Alabama. Yeah, the university has more than 38,000 students. They have an ocean of data. In the past, when there were no real solution to analyze so much data, some of them will seem useless. Nowadays, the administrators are able to use the analytics and the data visualizations for the data to draw out patterns of the students, so they can see how the university operation, recruitment, retention, everything. And about the healthcare industry with the big data, we can reduce the cost of the treatment. Scientists can predict epidemics, and preventable diseases can be detected as early as possible. And medical research can identify symptoms and provide past medical results research and make better prescriptions. So here we have an example with the Apple HealthKit. So the wearable devices and the sensors have been introduced to our life and in the healthcare industry also. And it provides real-time and feeding the electronic record to the patient. One such technology is from Apple. Now, Apple has come up with the Apple HealthKit, CareKit, and ResearchKit. The main goal of it is to empower the iPhone users to store their access and their real-time health records on their phones. And now we can see the big data in the media and entertainment industry. Well, they just predict the audience interest, target ads effectively, optimize recommended video and links, and insights into the customer's reviews. For example, the Spotify and Amazon Kindles. Spotify is a very popular on-demand music providing platform. They use big data analytics to collect data from all the users around the globe. And it uses and analyze data to give the information, music recommendations and suggestions to every individual users. Amazon Prime that offers video, music, and Kindle books in one-step shop, also with the big data. Big data in the weather patterns. Well, we can use this in the weather forecast, the global warming research, understanding the natural disaster patterns, and forecast the global water availability. And finally, we can make the necessary preparation in the event of crisis. For example, IBM Deep Thunder. IBM Deep Thunder, which is a research project from IBM, provides the weather forecasting through high-performance computing of big data. IBM is also assisting Tokyo with improved weather forecasting for the natural disasters or predicting the probability of damaged power line. Big data computing requires appropriate platform and tools. When mining the large number of data sets, the structured and unstructured data exists for discovering hidden rules. Big data computing tools need to be capable of parallel computing and distributed computing. Big data tools. There are various frameworks and platforms can be used to construct big data analysis system, such as the Hadoop. It is an open source big data framework that supports data-intensive distributed application, or the so-called HDFS, the Hadoop Distributed File System. That is a system that can store a large number of data sets on different nodes. And the MapReduce, it is a distributed data computing framework, and Spark MLI, Flink ML, the machine learning algorithms libraries. Cloud tools and programming languages. In terms of data analysis, depending on the purpose of the project, you can use the cloud service or use the programming language to construct your algorithms. Say, the cloud tools, we have the Microsoft Azure machine learning, IBM Watson machine learning. And the programming languages we often see, the PIG Latin, the Python, Julia, Go, or R. And then we have lots of visualization tools. There are different tools for cloud platform, websites, mobile platform, and some of them are free or you have to pay. The graphical method suitable for the project is mainly selected according to the methodology you use. Machine learning comes from the accumulation of human experience. The way of human learning is to accumulate through experiences, such as when we were young, adults told us, this is the tree. For the computers, we want to teach the computers to understand trees. So we want to teach computers to we will have to write all the rules related to trees through programming languages, such as the leaves, the trunks, the roots in the soil, and etc. It may take dozens of rules to achieve a certain accuracy in identifying a specific tree species. And one new tree species or deformed tree appear, the rule may not be effective, and the rules has to be rewritten. So is there a better way for computer to learn how to recognize the trees through the experience, just like human? The method is machine learning. We let computers to see a very large number of trees, including various tree species and a weird-shaped tree, and let the computer, just let the machine generate a model to determine the tree by itself. So that's the learning process of the machine, and throw it into the model when we see the new trees in the future. You can just judge whether it is the tree. This is an illustration of the ancestor of machine learning, perception. Machine learning requires a lot of data. The data with the target answer is called labeled data. So you can see here, we have lots of face here, and it's labeled. They are all labeled with face. The car here, the elephant here, the chairs here, they were all fed into the machine and help them to learn the labels. Here we have an example. The Tesla highway piercing arrow hits a truck. After some preliminary investigation by the National Highway Police, the Tesla driver turned on the vehicle assistance system at the same time. The speed was about 110 kilometers. However, when the driver found the truck, it was overturned. The driver immediately stepped on the brakes, causing the entire vehicle to brake less than the hits from the previous vehicle. But why don't the Tesla vehicle assistance system recognize the overturned truck? Tesla's self-driving car system is realized by the computer imaging technology based on machine learning. The driving assistant driving system that rely on the visual recognition of the outside lens of the car, they has always been difficult to judge stationary objects in the high-speed status. Therefore, if the object dropped in the center of the road, or the car body in the accident is stationary, the system cannot distinguish it. In addition, the overturned car body is all in the same color. If the Tesla self-driving car system doesn't have the experiences, it will not be distinguished. So you can see the picture again. Yeah, it is just in front of the Tesla. So the camera of the car see a white wall. So the machine doesn't have the experience, so he doesn't know what to do.